So welcome. This is a test number 5 based on derivatives of IBDP AAHL. Let's start the first question. 1 upon sine. 1 upon sine can be written as cosecant. Cosecant x power 4 plus 1. So what will be the derivative of cosecant x? Minus cosecant x power 4 plus 1 times cot x power 4 plus 1. X power 4 derivative is 4x cubed. Part B, g of x, sine inverse x derivative. Sine inverse x derivative is 1 upon 1 minus x square, x power 4 plus 1 whole square. And chain rule, x power 4 derivative is 4x cubed. Then again, f prime x will become power rule first. Sine power 3, x power 4. Sine x power 4 derivative is cos x power 4. X power 4 derivative is 4x cubed. So answer will be 16x cubed sine cube x power 4 times cosine x power 4. Now show that from first principles. What is first principles? Limit h approaches 0, f of x plus h minus f of x upon h. So limit h approaches 0, x plus h whole square plus 1 upon x plus h minus 3 minus x square plus 1 upon x minus 3 total divided by h. Now expand that one. Limit h approaches 0, x square plus 2xh plus h square plus 1 upon x plus h minus 3 minus x square minus 1 upon x plus 3 divided by h. X square cancels, plus 3 minus 3 cancels. Then I give these two fractions. So it becomes limit h approaches 0, 2xh plus h square plus 1 upon x plus h minus 1 upon x divided by h. So limit h approaches 0, 2xh plus h square. Common denominator is x plus h times x. X minus h divided by h. X gets cancels. Now we know that h is 0, so this before that one h can cancel, one h, and a h gets cancels. So what am I left over with now? Limit h approaches 0, 2x plus h minus 1 upon x plus h upon x. Now we know that h is 0, so wherever x is there, if at all I write 0, it becomes 2x minus 1 upon x square. Question number 3. Y equals to f of x whole cube. So what will be dy by dx? Dy by dx will become 3 f of x whole cube times f prime x. Now I want dy by dx at x equals to 1. So dy by dx at x equals to 1. So it becomes 3 f of x, f of 1 whole cube times f prime of 1. So which is 3 times 2 square. F of 1 is 2 and f prime of 1 is 5 times 5. So answer is 20. Coming to the part B, y equals to f of x square. So what will be dy by dx? Dy by dx equals to f prime of x square. X square derivative is 2. Now I want dy by dx at x equals to 2. F prime of 2 square times 2 times 2, which is going to be f prime of 4. F prime of 4 times 4. What is f prime of 4? 6. 6 times 4. So answer is going to be 24. Next part C, y equals to f circle f of x. So f circle f of x means f of x. Now dy by dx will become f prime, first outer function. Every time outer function is f. F prime of f of x. Now inside function. Inside function is f of x. F prime of x. So Now I want dy by dx at x equals to 1. So it becomes f prime of f of 1 times f prime of 1. F prime of f of 1. What is f of 1? F of 1 is 2. F prime of 1 is 5. 2 and 5. Now f prime of 2. F prime of 2 is 4. So 4 times 5, which is 20. The point 1 comma 1 lies on this one. Find the value of this. So substituting 1 comma 1, 1 square times 1 cube plus a equals to e power 1 times 1 minus 1. So 1 plus a equals to e minus 1. So a equals to e minus 2. Find the equation of the tangent line and equation of the normal line. So I'm going to find the derivative by product rule. This is u, this is v. X square, y cube derivative, 3y square, dy by dx. Next time y cube as it is, x square derivative, 2x. A derivative, 0. E power xy derivative is e power xy, chain rule. X dy by dx plus y times 1 minus x derivative, 1. Now I'm plugging it out, 1 comma 1 in this. So it becomes 3 dy by dx plus 2 plus 0 equals to e dy by dx plus 1 minus 1. So I take dy by dx common, 3, and over here it is there, minus e equals to e times 1 is e minus 1 plus 2 goes to the other side, minus 2. So dy by dx equals to e minus 3 divided by 3 minus e, which is minus 1. So slope of the tangent is minus 1. So tangent line will become y minus y1 equal to m times x minus x1. So y equals to negative x plus 2. Now slope of the normal will become 1. So what will be the normal line? Y minus y1 equals to m times x minus x1. So y equals to x. Now question number 5. I know that this is the difficult one. It is being done. The diagram shows the f of x now, which has 3 stationary points. This is one stationary point, this is one stationary point, and this is a stationary point. Find the graph for f prime x. So the derivative. Now over here it is an increasing function, and from a to b it is a decreasing function, and again it is increasing function, and again it is increasing function. Increasing, decreasing, increasing, and increasing stationary points. At A, there is a stationary point, so first derivative is 0. At B, the first derivative is 0. And at C, the first derivative is 0. These are the 3 points. Now, over here, the slope is positive and it becoming 0. Positive and becomes 0. Over here, the slope is negative and it approaches 0. Negative and it approaches 0. Over here, again it is positive and approaches 0. Positive and approaches 0. And again it is positive. Keep on increasing. This is going to be the graph for f prime x. Now I have to prove for f double prime x. So, an absolute value of f double prime x. So, for this one, slope, now this is, for example, we find it out this as a function. Now, slope of this one, slope of this graph is going to be the graph for f double prime x. Then later we'll think about the absolute value. So slope of this one. So now this part is decreasing and it continues to decrease. Over here it is 0. So over here second derivative is going to be 0. Over here the second derivative is going to be 0. And we know that at point of inflection. At point C also, the second derivative will be equals to 0. This will be our point of inflection. That is also equals to 0. So I get it out 0 over here, 0 over there, and very close by, this is going to be the point of inflections where the second derivatives are 0. Now, carefully, the slope is positive and over here negative. The slope is, the graph is positive and negative, and the slope is going to be 0. It is coming to 0 and it is coming over here negative, and still it is negative. So now we can come to know that. Let me erase this part and write neatly over here. Now we can see that this is the graph for f prime x, and we have to draw the graph for f double prime x. F prime x and f double prime x means we have to find the derivative, as if we will think as if this is f of x, and we'll try to draw it out. Maybe we'll think it as g of x and we'll try to draw it out g prime x. So because from function to derivative is much more easy. So now over here it is decreasing, decreasing, and it is decreasing till here. That is our point of inflection. It keeps on decreasing from the positive side. So it keeps on decreasing. Now from here it is increasing and it is becoming 0 till the next point of inflection. It increases, and it becomes 0 again. So it is going to be in this way. Now for the next part, from here again the graph is decreasing and becoming 0. Decreasing, the slope is decreasing and becoming 0. From there again the slope is keeping on increasing. Slope is keeping on increasing. So this is the shape of the graph. Just think about the slopes. That will be the easiest way. So first find point of inflections, mark them on the x-axis and think it as a slope. Now but he's asking absolute value. So this down part also becomes up part. So this is going to be the shape of the graph. So the down part is deleted. This will be the final shape of the g double f double prime x. This upon practice you will be coming to know. Question number 6. The total surface area of two cubes is 300 centimeters square. So there is one cube over here. Let me draw neatly. I'll draw in the form of a square. That will be much more easier. This is one cube and there is another bigger cube. This is x, this is y. Total surface area TSA is 6x square plus 6y square. This should be equals to 300. So x square plus y square equals to 50. So y equals to square root of 50 minus x square. Find and y in terms of x. Find the minimum total value corresponding dimensions. Total volume will be x cube plus y cube, which is x cube plus y is 50 minus x square to the power of 3 upon 2. Now dv upon dx equals to x cube derivative 3x square, 3 upon 2, 50 minus x square whole power 1 upon 2 minus 2x is going to be the derivative of that. When I try to simplify, it becomes 3x minus 3x 50, then times square root of 50 minus x square. Now dv by dx should be equals to 0. So 3x square minus 3x square root of 50 minus x square should be equals to 0. 3x square equals to 3x square root of 50 minus x square. So x equals to square root of 50 minus x square. Squaring on both sides, x square equals to 50 minus x square. Then it becomes 2x square equals to 50, x square equals to 25, x equals to 5. So find the second derivative, d square v by dx square. This is 6x minus 3 root of 50 minus x square. Chain rule, I'm doing it a product rule, plus this time 3x as it is. Square root of this one is 2 root of 50 minus x square, and minus x square derivative is 2x. Now I'm going to plug in this x equals to 5 in this. When I'm going to plug in x equals to 5, so it becomes 6 times 5 minus 3 square root of 50 minus 5 square, and this becomes plus 2 gets cancels, 3 times 5 square divided by square root of 50 minus 5 square. We can see that this value is going to be a positive value, so therefore the volume is going to be minimum. Now therefore we could able to get it out x equals to 5. What is he asking? We have justified our answer. Corresponding dimensions of two cubes, so x and y. We know that x square plus y square is 50. So x square plus y square equals to 50. So 5 square plus y square equals to 50. Y square equals to 25. So y equals to 5. So therefore the second cube is also 5. So total volume will be 5 cube plus 5 cube, which is 250 centimeter cube. Question number 7. Find the tangent lines to the curve y equals to x power 4, which is passing through. So equation of tangent will be y minus y1 equals to m times x minus x1. So y equals to mx minus 48. This is the equation of the tangent. Now every time let this be f of x and this will be g of x. Every time f of x equals to g of x and f prime x equals to g prime x. F of x equals to g f prime x is derivative of this one, slope is m, and the slope of this one is x cube, x power 4 derivative 4x cube. Over here x power 4 should be equals to mx minus 48, but m is 4x cube, so x power 4 equals to 4x cube times x minus 48. X power 4 equals to 4x power 4 minus 48. 3x power 4 equals to 48, x power 4 equals to 16, x equals to plus or minus 2. If x equals to plus or minus 2, plug in this x value to get the value of m. 4 times plus or minus 2 whole cube, which is plus or minus 32. So if at all it is plus 32, it will become 32x minus 48. If minus 32 minus 32x plus 48, this will be the equations of the tangent lines. 32x plus 48, and over here the equation was mx minus 48. So plugging in that one, 32x minus 48 and minus 32x minus 48 is going to be the answer. So see carefully for the symbols. Now question number 8. Find the three derivatives. So f prime x will become 2 e power 2x minus e power minus x. F double prime x 4 e power 2x plus e power minus x. F triple prime x 8 e power 2x minus e power minus x. Then guess the formula for f power n, nth derivative. Nth derivative of x will become 2 power n e power 2x plus minus 1 whole to the power of n e power minus x. Prove by mathematical induction that your guess is correct. So for n equals to 1, left hand side f prime x will become 2 e power 2x minus e power minus x. Right hand side will become 2 power 1 e power 2x plus minus 1 whole power 1 e power minus x. So which is 2 e power 2x minus e power minus x. Therefore the statement is true for n equals to 1. We assume it is true for n equals to k. So kth derivative of x equals to 2 power k e power 2x plus minus 1 whole power k e power minus x. We need to prove it for n equals to k plus 1. So k plus 1th derivative of x equals to 2 power k plus 1 e power 2x plus minus 1 whole to the power of k plus 1 e power minus x. So that we have to prove it. So basically k plus 1th derivative means nothing but what? I take the kth derivative, then find the derivative of that. So kth derivative's derivative. So it becomes 2 power k times 2 e power 2x plus minus 1 whole power k minus e power minus x, which becomes 2 power k plus 1 e power 2x minus 1 whole power k and minus 1 e power minus x. So it becomes 2 power k plus 1 e power 2x plus minus 1 whole power k plus 1 e power negative x. Then you can write the conclusion. Question number 9. Again, a ladder of 10 meters is there against a wall, and the bottom of the ladder means dx upon dt equals to 0.5. Calculate the speed of the descent of the top, dy upon dt equals to question mark, when the ladder is 6 meters away, x equals to 6. So we know that it follows Pythagoras theorem, x square plus y square equals to 100. So 2x dx upon dt plus 2y dy upon dt equals to 0. So x dx upon dt plus y dy upon dt equals to 0. So 0.5 times x, x was 6, plus y dy upon dt equals to 0. So dy upon dt will be minus 3 upon y. What is y? From here x was 6, so which is 36. 36 plus y square equals to 100, y square equals to 64, y equals to 8. So plug in 8, minus 3 upon 8 meters per second. Calculate the area of the rate of the change of the area of the ladder and the ground the moment the triangle is isosceles. So I want to find the area of a triangle. Area of a triangle is half times base times height. Half times base is x, height is again 100 minus x square. Now I want dA upon dt, which is 1 upon 2. Change what is this? I'll use product rule. X derivative is dx upon dt, square root of 100 minus x square plus 1 upon 2 x Root derivative is 1 upon 2 root of 100 minus x square, and x square derivative is minus 2x. Again, dx upon dt. Don't forget to write dx upon dt. So what is dA upon dt will become now? 1 upon 2 dx upon dt was 0.5 square root of 100 minus x square minus 1, 2 and 2 gets cancels. 0.5 upon 2 square root of 100 minus x square, 100 minus x square. So what does that becomes now? And again x times x is x square. So what does that becomes? 0.25 square root of 100 minus x square minus 0.25 x square divided by square root of 100 minus x square. When it is an isosceles triangle, x equals to y. So x square plus x square should be equals to 100. 2x square equals to 100. X square equals to 50. Plug in that x square equals to 50. So it becomes 0.25 square root of 100 minus 50 minus 0.25 times 50 divided by square root of 100 minus 50. So which is going to be 0.25 square root of 50 minus 0.25 square root of 50, which is going to be 0. Finally, explain the result C of B. So we got area is going to become 0. So what do I am going to write it out? Rate of change of area is equals to 0, means we have maximum area. Maximum area means it is basically a stationary point. Question number 10. Find the domain and the range. Domain, we know that ln x domain is x is greater than 0 because only positive numbers I can substitute. And the root of the function. Root of the function means f of x should be equals to 0. So ln x upon x square should be equals to 0, means ln x equals to 0, means ln x equals to ln 1. So x equals to 1. Find the coordinates of the stationary point. For finding the coordinates of the stationary point, first derivative, so it becomes x power 4, 1 upon x times x square minus 2x ln x, which becomes 1 minus 2 ln x upon x power 3. Now f prime x should be equals to 0. So 1 minus 2 ln x should be equals to 0. Ln x equals to 1 upon 2. So x equals to e power 1 upon 2. Now plug in y ln e power 1 upon 2 upon e, 1 upon 2e. So the point is e power 1 upon 2 comma 1 upon 2e. Next, find the and determine its nature. So what am I going to take? I am going to take the table f of f prime x square root of e. Then if at all I take any value of that one, square root of e less than that one, maybe 0 I take, I'll be getting it at the first derivative positive, and I take a number, maybe 1 I take, it becomes negative. So it becomes positive, 0 and negative. So it's going to be a maximum point. Part C, find the coordinates of points of inflection, justify your answer. For point of inflection, I should find the second derivative. So it becomes x power 6 minus 2 upon x times x power 3 minus 1 minus 2 ln x times 3x square. So it becomes minus 2x square minus of minus 3x square plus 6x square ln x divided by x power 6. So it becomes minus 5x square plus 6x square ln x divided by x power 6. So 1x square gets cancels, x square and x power 4. So minus 5 plus 6 ln x upon x power 4. Now for point of inflection, second derivative should be equals to 0. So minus 5 plus 6 ln x should be equals to 0. So ln x equals to 5 upon 6, x equals to e power 5 upon 6. So what is y value? Ln e power 5 upon 6 divided by e power 5 upon 6 whole square, which is 5 upon 6 divided by e power 5 upon 3, which is 5 upon 6 e power 5 upon 3. So what is the point? E power 5 upon 6, comma 5 upon 6 e power 5 upon 3. Now we need to justify this one, whether it is a point of inflection or not. So I take the table, second derivative, e power 5 upon 6, and take any value less than that one, I get negative, concave down. Value more than that, maybe I can take e only, I get a positive, which is concave up. So concavity changes, it is a point of inflection. Part D, sketch the graph and write down the range of the graph. Now we know that at square root of e there was a maximum point. Square root of e there is a maximum point. Point of inflection is at e power 5 upon 6, and at 1 it is equals to 0. So this is a maximum point and it's going to be a point of inflection. Maximum point and passing through point of inflection. This should be the shape of the graph. Now he's asking range. Range means it is the maximum point. What was the maximum point's y value? 1 upon 2e. So y is always less than or equals to 1 upon 2e. Question number 11. Consider the graph y equals to square root of x and its reflection on x equals to 4. Square root of x looks like this. X equals to 4 is over here and its reflection will be in this way. This is x equals to 4. If x equals to 4, this value will be equals to 2. Now there is a rectangle. This value is x. Find the area enclosed by the between the two curves. So this is based from integration. If at all you wouldn't have done integration, no need to do this question. 0 to 4 square root of x dx. So 0 to 4 x power half dx. So which is x power 3 by 2 upon 3 by 2 from 0 to 4, which is 2 upon 3 x power 4 power 3 by 2 minus 0 power 3 by 2, which is going to be nothing but 16 upon 3. This is for one graph. There are two graphs to the other side also. 2 times 16 upon 3, 32 upon 3. If at all you haven't done the integration, you can leave this part for a moment. Then a rectangle is drawn that the lowest of the vertices are on the x-axis and the upper vertices on the curves are g and g prime. The area of the rectangle is denoted by s. Find the maximum value of s. Justify your answer. Now this is 4 minus x, so this part is also 4 minus x, and the height is going to be square root of x. So area equals to base times height, which is 8 root x minus 2x to the power of 3 by 2. Now the first derivative ds upon dx is 8 upon 2 root x minus 2 times 3 upon 2 x power 1 upon 2. So it becomes 4 upon root x minus 3 root x. Now ds upon dx should be equals to 0. In that case, 4 upon root x minus 3 root x should be equals to 0. 4 upon root x equals to 3 root x. So 4 equals to 3x, x equals to 4 upon 3. Find the second derivative. It becomes 4x power minus half minus 3x power half derivative. So it becomes minus 2x power minus 3 by 2 minus 3 upon 2 x power negative 1 upon 2. This is always negative. So therefore, it is going to be a maximum point. So therefore, area will be 8 minus 2 times 4 upon 3, then square root of 4 upon 3. Simplify that, you should be getting 32 upon 3 root 3. That's going to be the answer. That completes the paper. See you in the next video. Bye.